All right, so we're going to graph simple rational equations. First of all, understand this. A rational function is a function in the form y equals some polynomial divided by another polynomial, where the one on the bottom can't equal to 0. All right, so that's what it is. Keep in mind, rational begins with the word ratio. So when we think about rational, we think about a ratio being a fraction. And important, that fraction then has a variable at the bottom to be a rational expression. All right, so in this case, they're not really polynomials, they're two polynomials divided into each other. Great example of a rational expression is y equals 1 over x. It's a rational expression because unique things happen here. For one, in this equation, y equals 1 over x. X has limitations. X cannot be 0. X can be any number except 0, but it can't be 0. Meaning that the domain of this function is all real numbers except 0. Or, as an inverse notation, it would be from negative infinity to 0. 0 is not included, so I use a parenthesis, and then a union, 0 to positive infinity. So that would be the domain of this function. And the reason why x can't be 0 is if you plug in 0 for x, you get 1 over 0, which is undefined. You have no value for it, and you can't use it in math. So because of that, x can't be 0. And because x can't be 0, that leaves out some stuff that y can't be either. For example, if you look at this equation, y equals 1 over x, pause the video and tell me the number that you should plug in for x to make the output 0. So I'm going to ask the question again. What number should you plug in for x to make the output 0? So pause the video and tell me, or not tell me, figure out what number you can plug in for x for the output to be 0. Do that now. So you may have gave it a guess. You may have tried some numbers. You already knew you couldn't try 0. You may have tried 1. You plugged in 1, you got 1 over 1. You may have tried a lot of numbers, but you couldn't find a number that you could plug in for x, so the output would be 0. So because of that, y can't equal 0 either. Coincidentally, in this problem, y can never be 0 because you can't find a number to plug in for x to make the output become 0. So because of that, when we actually graph this, if x can't be 0 and y can't be 0, we actually try to graph this function. You have outputs all over the place for x. I could make a table of values, I could plug in numbers for x and y, and I could try to plot this function. Let's go ahead and do that. So this is going to be my input column, x, and the output column for y. I'm going to choose input these numbers. Even though I said y can't be 0, x can't be 0, we already know this number is going to be an output that's undefined. But let's start with input -2. So you took this equation, you inputted -2, and you wound up having -0.5. So input's -2, output's -0.5. Input's -1, you get -1. So this place, output's -1. At 0, don't have an output, undefined. But input 1 into this equation would be y equals to 1 over 1, which is 1. Great. Output's 1. I plug in 2, 1 over 2. Output is positive 0.5. Let's actually plot those points. -2, -5 is a coordinate. So let's use these points. So at -2, -0.5, I'll say it's about right there. And at -1, -1, I'll say that's about right there. At 0, it is undefined. Because it's undefined, put a checkered line right here. So I can't cross that number. This is called an asymptote. It's a number our graph can approach forever but never truly cross. Just to be honest, sometimes you can't cross it, but it definitely will approach forever. It's got an asymptote here. It will never actually be that number. And for that matter, we said y can't be 0. So true, we have an asymptote here as well. We can approach these numbers forever, but we can never find a value to actually become that. So anyway, other points were 1 and 1. So I plug in 1, I get output of 1. 2 and 0.5. So I plug in 2, this is actually a decimal space right here, not a negative. So it's 2 and positive 0.5. So 2, I get 0.5. But you may not see enough with just those 2 points to actually come up with the curve. Like you only see 2 dots there. You don't really know what's happening. Let's go use some more points. Let's go use -3, -4, -5, and for that matter, +3, +4, +5. So at -3, my output is -0.33 repeating. At -4, my output is -0.25. At -5, my output is -0.2. If you try the positive versions, you may think they look kind of familiar. It's 0.3 repeating. This is going to be positive 0.25. This is going to wind up being positive 0.2. So all the answers are the same now, just positive 0.3 repeating, 0.25, 0.2. So if we want to apply those points, add -3 is 0.3 repeating. It's a little bit higher. And -4 is a little bit higher, it's at 0.25. And -5 is a little bit higher, it's at 0.2. So I'm kind of seeing this graph is doing this as I get closer and closer to it. If I chose numbers in between 0 and 1, I'll see this graph approaches this line but never crosses it either. And at these points, like 0.33, 0.2, 5.2, so it's kind of doing this. So it's going to approach those asymptotes forever but never actually cross them. All right, so this is the graph of the function y equals x. Y equals 1 over x. This graph is actually, by definition, a hyperbola, which is a type of conic section where we have one end and it's symmetric about the line y equals x. Like if I drew the line y equals x right here and folded my graph down that line, there'd be a mirror image on that side, or if I drew the line y equals -x and folded my graph down the line y equals -x, there'd be a mirror image on both on that side as well. If you photograph down either one of those lines. Anyway, so it's a hyperbola, and that's what the graph looks like. That's a very basic rational function. But basically, every other rational function kind of relates to that. So understand this. A rational function is generally in the form y equals to some number over x subtract h plus some number k. Where, in this case, I don't have a number k, so it's a plus 0 here. I don't have subtract h, so it's a subtract 0 there. So it's kind of boring because I don't have very much shift involved. But what we're going to find is this k gives me my vertical shift. And we're going to find that this h gives me my horizontal shift. Let's actually rewrite this bigger, and let's actually look at a lot of those in that form. So right now, take out a graphing calculator, or go on my website and use my graphing calculator, and graph each of these functions, A, B, and C. You can graph them all at the same time, or one at a time, so you can kind of see what's happening there. But I suggest you graph each all at the same time. You kind of see what happens there. And then maybe change the equal sign from being darkened or whatever, so you can actually see this one of them. But anyway, graph each one of these and actually draw the graph right beneath there. All right, you have that, pause the video, write down those equations and graph each one. But I should say this, if you're going to graph this binomial on the bottom of the fraction, you have to make sure the calculator knows all that's on the bottom by putting in parentheses. Same case with these binomials. They should have parentheses around the denominator, so the calculator knows all those are the quantity in the denominator. So when you graph this first one, you should have saw that you have an x-intercept, you have a vertical asymptote at -3. So x cannot equal to -3. So because of that, at -3, I have a vertical asymptote. So this is -3. As a vertical line, this graph can actually cross. Also, you're going to notice here I have this graph has a horizontal asymptote at 0. It won't actually ever be 0. I can explain that a lot of different ways, but basically I think the easy way to understand it is this. If you have this fraction, right next to it is plus 0. So that tells you what your horizontal asymptote is. Whatever this number is being added next to it tells you that the line that would be a horizontal line that the graph won't actually cross. Other than that, it's not much different from your last graph. You should have saw that has a curve that does this on this side of it and on this side of it. But it doesn't actually cross this line. Approaches it forever, but it doesn't actually cross it. So basically what makes this part 0 is your vertical asymptote. It's kind of important to know. Whatever, let me pause this. Whatever value of x that causes your denominator to equal to 0 is a vertical asymptote, or for that matter, or a hole. Get the holes later, but it could be one of the two. It could be a vertical asymptote or a hole. I'm going to tell you now, it's a hole if this actually cancels with one of the factors of the numerator. You won't see any of that in the one you look at tonight, but that's where a hole occurs when a factor here cancels with the factor in the numerator. So look at the second one. We should have saw that we had a vertical asymptote at 3, because x cannot be 3. So here at 3, got a vertical asymptote, and then this is still plus 0 in the end. So there's a horizontal asymptote here. So here's the graph. And in this one, even though I have a 3 on top, it has no effect on what the vertical asymptote is or horizontal asymptote is. If I had an x on top with it, it would change some things. But since it's just a constant there, it doesn't change anything. So my vertical asymptote is still going to be at x cannot be 5. So at 5, I have a vertical line that won't cross. And it's still plus 0 there. The horizontal line at 0. And this is the curve. So basically what you see is the numbers on the bottom, they give you a transformation. This transformation is shift to the right, 5. This transformation shifts to the right, 3. This transformation shifts to the left, 3. So basically you see that these signs give you what transformation is, but it's pretty much the opposite of those signs when there's linear term there. So that's the basis of the simple rational function. Give you a couple more though. Okay, so pause the video, write down these 3 equations. I actually want to tell you how to graph them. So I'm gonna add more stuff to the screen. All right, so let's first find a vertical asymptote. How we find that is, we set the denominator equal to 0. We saw that equation. A vertical asymptote is 4/3 after I saw that equation. So that's 1, this is 2, 4/3 is about right here. That's my vertical line that we would never cross, 4/3. We also have a horizontal asymptote. In this case, it isn't 0. If you notice, I can have plus 0 on the end there, but that really affected this time. The reason why is, in this case, I have an x in the denominator and an x in the numerator. Because of that, my horizontal asymptote is going to be the leading coefficient divided by each other. So if that's the case, my horizontal asymptote, call it HA, is 1 divided by 3. So to find a horizontal asymptote when it's really in this form, you really look at the fact that is this being, can you actually reduce this fraction? You get 1/3. So if this is 1, 1/3 is about right here. Other than that, everything else remains the same. This is one end of the curve, this is the other end of the curve. And that's what the graph looks like. All right, so pause the video, see if you can graph B and C on your own. So pause it, and then stop talking, let you graph B and C on your own. So just go for it. Don't be afraid, pause the video and go for it. Good luck. So the first thing I noticed in this problem was that the x value here, there's an x value in the bottom and not in the top. So we don't have to follow this rule, horizontal asymptote being 1 divided by 3, because in this case x is in the numerator, in this case it isn't. In this case, my horizontal asymptote is right here. So then my horizontal asymptote is -2. Sorry to draw a line at -2. My vertical asymptote is what makes that 0. You can kind of see that's -1. So at -1, I have a vertical asymptote. If you're not sure, you set that equal to 0. Subtract 1. And you get -1. So from there, notice also that 6 is negative. It affects the graph by, instead of being on this side, it flips it. It's now on this side. And the other piece is down here. And that'd be the curve for it. What you should have found in this last one was that my horizontal, should have found that the horizontal asymptote was 30/15 or 2. Vertical asymptote was 3. That would make this part 0. So the graph's like this. That's pretty much all I have. Good luck.